Hello, this is Mrs. Rodolfi, and I wanted to go over lesson 20, practice with simplifying radical expressions. So I'm going to go through some of these on this first page, 1 through 6 I'm going to do, and then you will do the rest for practice and use the key I also posted on the course calendar to check your answers. So when we're simplifying radical expressions, when we're adding, we need to have the same radicand. So the radicand is the number under the radical symbol. So like square root of 6. 6 is the radicand. So it's kind of like almost like a variable. Like if they both had, 3x plus 5x, then we could combine them. So then we're just going to add the number in front of the radical symbol, 3 plus 5. Which is 8, and then we'll just keep it the square root of 6. And the way we say this is 8 times the square root of 6. Simplify the square root of 6 any further, so we're just going to keep it right like that. Then when we're subtracting, same thing. As long as the radicand is the same, we can combine like terms. So they both have the square root of 7. So we're going to look at the numbers in front. 10 minus 8 is 2, and then times the square root of 7. These both have the same radicand as square root of 3. Minus 9 is negative 6, and then times the square root of 3. Over here, number 4, same radicand, radical, square root of 7. So we can do negative 10 plus 12, which is 2, times the square root. We have the square root of 21, so we can combine like terms. Negative 11 minus 11 is negative 22, times the square root of 21. And then last one I'll do, these both have the square root of 3. So negative 10 plus 12 is 2 times the square root of 3. All right, try the rest on your own and use the key to check it. And then go to the back and I'll do some more on the back. All right, now we're getting into dividing and multiplying with radical expressions. So when we are dividing or multiplying, we are going to do that operation with the radicands and then with the numbers in front of the radical symbols. So like the square root of 6 divided by the square root of 27. First, you want to see if you could simplify it any further. See if there is the greatest common factor between the two, and then you can divide both sides. So it's just like with any fraction. If we divide a lot easier if you do that first. So like 6 and 27. I know that both of those have a factor of 3. So I'm going to divide both sides by 3. And that's going to give me the square root of 2, because the square root of 6 divided by 3 is the square root of 2. And then the square root of 27 divided by 3 is the square root of 9. Now I have some smaller numbers. It's a little easier to work with. Then see if you can actually simplify by finding the square root. So the square root of 2, that is an irrational number. That's going to give you a non-terminating, non-repeating decimal. So we're going to keep that as the square root of 2. But the square root of 9 is a rational number. That equals 3. So that is my final answer. All right, 14. Same thing. Do these have a common factor between the two? Yes, they do.
Clinton Grigsby
Divided by 4.
Clinton Grigsby.
We're going to simplify. So the square root of 8 divided by 4 is the square root of 2. The square root of 100 divided by 4 is the square root of 25. And then, again, see if you can actually find the square root with a rational number. Square root of 2, irrational. Keep it like that. Square root of 25 equals 5, because 5 times 5 equals 25. So this is our final answer. Now, problems like number 15. in the denominator. We cannot have that. That's irrational. We have to, what we call, rationalize the denominator. So to do that, you have to multiply both sides. All right, when we have a number that's not under the radical symbol and then timesing it by a number under the radical, we just keep them separate. 4 times square root of 5. And then when you have the square root of 5 times the square root of 5, those square root symbols cancel out. And I'll just kind of show you why. I'll break it down. So you don't even have to do that step. You can just know that the square root of 5 times the square root of 5 will equal 5. And then this is our simple. To keep that. All right, number 16. 3 times the square root of 20 divided by 2 times the square root of 4. Now, you can do a couple things. Now, this one I wouldn't divide both sides by it because I have 3 halves, and that's 3 halves. That is already in simplest form. And then you divide the numbers under the radical symbols, so your radicand. So 20 divided by 4 is the square root of 5. Because just like if, we did 20 divided by 4, it would just equal 5. And then that's like over 1, so 3 times the square root of 5 over 2. Again, we cannot have a irrational number in the denominator, so we must. Now, both square root of 5 and square root of 3 are under the radical symbol, so we can multiply those. 5 times 3 is the square root of 15. So that the square root of 15 any further, so that is our answer. All right, going over to number 18. All right, so again, there's like an invisible 1 in front of here. 1 divided by 3, that's going to stay 1/3. Then divide both sides by 5. So to simplify that further, 15 over 10 is 3 halves. So I'm going to keep that under. Then notice how there's an x on both the numerator and denominator. That's going to cancel out because if we followed the rule, it would be x to the first power minus the first. This y is like y to the first power. Remember, we subtract when they are quotients. So 1 minus 3 is -2, y to the -2. So now we need to continue to simplify this further. That when anything is under the radical symbol, and we went over this in the lesson, from lesson 20 in class, but if you have this, the 1/2. So now that I see that I have y squared in here, I can multiply 2 times 1/2 to have the square root of 3 over 3y times the square root of 2. Because, or you can think of it as divide it by 2. So anytime you have an exponent under the radical symbol, if you divide that number by 2, you can take it out. And so y squared radical on the denominator, so I need to multiply both sides by the square root of 2. These are both under the radical symbol. 3 times 2 is the square root of 6. And then I only multiply the numbers under the radical. So 3y times 2. I still can continue to simplify this. 3y times 2 is 6y, so it equals. And then to go over some, so try these two division ones on your own. When we're multiplying it, same kind of property, always multiply the number under the radical symbol and then multiply the numbers in front. So like 5, square root of 5 times. Now we can simplify this a step further. Go to your list of perfect squares. So like squared equals 16 and so on. If I find a factor of 50 that's a perfect square, I can simplify this further. I know that 25 times 2 equals 50. And I know that 25 is a perfect square. The square root of 25 equals 5. So I can take that. This is simplest form, 5 times the square root of 2. All right. Try for the solutions. What if we have a radical, so the square root of 5, and then times negative 4 times the square root of 20. So again, this is like then multiply the numbers under the radical. 5 times 20 is 100. Now I can still simplify this further. The square root of 100 equals 10. So this is like saying negative 4 times 10, and I get negative 40. All right, and then I just want to go over one more type of problem. So I'm going to jump to 26. So we have a number or a radical symbol on the outside of the parentheses. Again, think of distributive property. So if we have square root of 3 times 5 plus the square root of 3, we need to distribute this square root of 3 to every. So what we're going to do is do the square root of 3 times 5. Now, when I multiply this by 5, I take the number on the and put on. Then these both are under the radical symbol, so 3 times 3 is square root of 9. All right, 5 times the square root of 3, I can't, but under 3 plus 3. Final answer. And then for 27, same thing. 2 times the square root of 5 is on the outside of the parentheses. We need to distribute to everything inside the parentheses. And then check the key. I hope this video was helpful and you have a fabulous rest of your day.